before we go into determining contact information, I want to actually throw one more contact into this. A third one, and you'll see why in a second. And let's say we did it at basically the same time. So contact A we shot at 1500 and 1506. B was at 1501 and 1507. So by the way, I should make a note that if this time to CPA is in 36 minutes, it's actually 36 minutes from 1507, as opposed to contact A being 53 minutes from 1506. So there is that slight difference in time, though given the huge disparity between the two times the CPA, it wouldn't change the priority. However, that is another thing you need to keep in mind if you started measuring a contact far later than a different one. Those time to CPAs have to be adjusted to be relevant to one another. But let's say at now 1502, we took a shot, or we noticed contact C, and it bore 302 at 9.3 nautical miles. So we're going to measure out, and we're going to do all the information for this one. So first we're going to measure out 302, or that's 320, 302. Draw out that line. And we're going to extend it out to 9.3 miles. So there's 9.3. Good. Now, we waited 6 minutes to measure this one again. And while we were waiting those 6 minutes, we were doing the calculations for the other two. And at 1508, it bore 302 at 7.6 miles. Okay. So we're going to measure out 302. Draw our line again. And we're going to measure 7.6. And there's our M2. We'll write M1 and M2. Okay. Now you might already be catching on to why I chose those ranges and bearings. Because if there's a proverb, I guess it's a proverb, I don't know if it's a better thing to call it, but I guess word of wisdom that has probably been relayed to you so far in some way is the concept of constant bearing, decreasing range. And what an object with a constant bearing and a decreasing range is something bad, because it's on a collision course with you. Because if we now try to calculate its direction of relative motion by connecting the dots here, you can see we'll take M1, pass through M2, and if we extend its DRM all the way through, it hits straight at the center of our scope. That's us. That's where we are. So this thing is going to hit us. It's not going to pass a little bit away. It's not going to pass really close. It's going to hit us, guaranteed. If nothing changes, this contact is going to hit us. What is its range to CPA? Its CPA range is 0. It's just nothing. It's 0.0 nautical miles. What is its bearing of CPA? Null. There is no bearing of, or I guess the bearing is 302. The bearing is where it actually is going to be aiming when it collides with us. I know technically some people want the bearing to just be a perpendicular course, but that's not really accurate. The bearing is it's going to hit us. It doesn't, the CPA bearing does not matter. The CPA range is what matters because the CPA range is 0. So now this one is contact B is kind of a threat. Contact C is a huge threat because it's going to collide with us. And anytime you have, you measure a contact and it's two, M1 and M2 have the same bearing, 302 and 302, or 352 and 352, or whatever it may be, if it's just the same number twice, and the range is decreasing, it is coming to you. We don't know what its true course and speed are, but we know that its relative course and its relative speed are so that they will collide with you. So now let's find its relative motion to see if it's what time it's going to collide with us. Because remember, SRM is what we need to find time to CPA. So we measure out M1 to M2. And by the way, you're sweating while you're doing this. This was like nice and easy, whatever. You're sweating for this one because you know that it's going to kill you. Could kill you. We're going to get through this. Measure out the distance. Then you actually find what the distance is. So we've got 1.7 miles. So here's 1 mile. Here's 2 miles. Here's 1.75 miles because here's 1.5 miles. So we're going to go a little bit less than 1.75, so like that. And this was over the course of 6 minutes as well. So 6 minutes to 1.7. I hope you know where this is going because we've done it plenty now. We know how the 6-minute rule works. We get 17 knots. SRM of contact C. So contact C has a speed of relative motion of 17 knots. So that's faster than the other two. That doesn't mean that it's going faster necessarily. It just means that its relative motion is faster. So now what's its time to CPA? Well, its time to CPA is going to be how long it's going to take from M2 to the CPA point, which is us. Luckily, the one good side about contacts that are constant bearing decreasing range is we could measure out this distance here to find how long it's going to go before it's CPA, but it's the same as the distance of the second bearing because both of those now are relative to our position because both of those are being measured from here to here. So we know that this distance is 7.6 miles, and if I double check it, if I double check it, it gets to 7.6 right there. So it just happens to be the same distances, or no, it doesn't, but so we have a speed of 17 knots and we're going to go 7.6 miles, so it's just a little bit more than this, a little bit less than the 8. We connect the dots and we are going to get them together. "27 minutes. Okay, so contact C is on a collision course with us. It has a 0 nautical mile CPA, and its time to CPA is 27 minutes. That's better than I was expecting. I was just making up these ranges and bearings. You know, I've dealt with contacts that popped up and had a CPA of like 8 minutes. A time to CPA of 8 minutes and a CPA of like 0 miles. So even though this is on a collision course with us, we have 27 minutes. That's a lot of time. That's more than enough time to plan a maneuver to avoid it that will keep us alive. And time to execute while after even giving a report to the captain and everything. So the point of this was to explain to you what collision courses look like. It'll just be you take two ranges and bearings to a contact, and they both have the same bearing, and the ranges decrease from the first to the second. If they increased, obviously it's going away from you. It doesn't matter. But hopefully with this, you now have a good idea of how to just monitor contacts as they move along your radar scope. We don't know how to do any calculations with finding their speeds and courses yet, or how to maneuver for them, but this is just monitoring their motion in relation to you and all of the necessary important pieces of information you can get from that motion.